Hello everyone, welcome to our pre-calculus pre-recording video. So in this lesson we will be analyzing polynomial functions a little bit more, and we'll try to draw the graph. As we said that we have one full class for drawing polynomial functions, so we'll try in this lesson. These are the agenda. It looks like a lot of topics, but basically all of them are actually somewhat interrelated to our previous class. Determining the end behavior, x and y intercepts, determining whether the graph touches or crosses the x-axis at x-intercepts, like multiplicity. From multiplicity it will come. Determining the maximum number of turning points, it will come from the highest power or the degree. Then either or both, determine the behavior of the graph near each x-intercepts, plot additional points, and draw the graph. These are the steps that we will need to follow to draw the entire graph correctly. Looks like a lot, and when we will discuss it, it will look like also a lot. But once you all start practicing it a couple of times, then it will come into manageable position somewhat. Let's see. Okay, so let's review first of all the end behavior. So end behavior will depend on what? End behavior will depend on the maximum power of the function or the degree of the function. See, here x power is 1, here x power is 2, here x power is 3. So degree of this function is 3. This is the degree is 3. So that means this is the maximum power term. That means end behavior of this graph will depend on this minus x cube. So plus x cube graph is something like this. Plus x cube graph is, let me try it from this direction. Yeah, this is better. Something like this. I'm just drawing rough estimation. Actual graph will go through actually this point. This graph will, if I draw it correctly, this will go through that point. Okay. So now this is minus x cube. So basically, in this case, it will have some reflection in the other way. That means in this case, it will be something like this. Then something like this. Just to give you an idea. So the end part of this graph will look like this. Maybe this will come here, we do not know. Maybe this will go there, we do not know. We will know it from the other terms when we analyze, and of course we will do that in this class. So end behavior, what does it mean? It means how the end part of the graph will look like, and it will depend on maximum power. Okay, leading term coefficient. So how it will look, see, is the symbol is given here also. It will look like this. It will go this way and this way. So we know it for sure. Now to find out the x-intercept and y-intercept, what we do? Always remember, at every x-intercept, y value is 0. Suppose here, y value is what? Suppose here, y value is what? What is the y value at this point? What is the x value at this point? X value is 2, y value is 0. 2, 0. In this point, it is minus 5, 0. Just I'm giving you an example. On this line, everywhere y value is 0. That is the reason why we put y equal to 0 to find out the x-intercept. Because if we put y equal to 0, the resulting whatever remains there will give us the x-intercept if we put y equal to 0. Similarly, if we put x equals to 0, we will get the y-intercept. Let me explain it another way. Suppose if I draw something like this. So you see what will happen at this point. What will be the x value and y value? The x value will be 0 somewhere. Y value will be something. That's why in the graph, if you put x equals to 0, you get the y-intercept. This is opposite, just in your mind think it as opposite. If you put x equals to 0, you get y-intercept. If you put y equal to 0, you get x-intercept. This way you can keep it in mind. So here we try to find out the x-intercept. This is written here. Okay, so fx equals to 0, we put it here, then x equals to 0 will come, and x equals to 3 will come from here. And if we put f of 0 equal to what? If you put 0 here, see, 0 comes. That means this is our y-intercept, and this is our, of course, this is, it looks like this is x-intercept also. So here both of them actually intersects, x-intercept and y-intercept, both of them at 0. So that's why we have this one common point in this case, and then 3, this is the point. So up until now, what we got? Up until now we got, from this we got the end behavior, and then by analyzing it we can find out the x and y intercepts. These two information we found. We will get more. Okay, now let's look at this point, is it touch or cross? At this point, is it touch or cross? How we will know that? We will know it from their multiplicity. The x, for the x, multiplicity is 1. That means it will cross. And for the x minus 3, multiplicity is 2. 2 is even number. That means here the graph will touch. So from this we know these two things. It's written here. See, so the graph will be like this. This is our cross, this is our touch. Now you can say, sir, I have a question. You can say that, okay, we know that this is touch, but how do you know that this is not like this? This is also touch. This is also touch. You can say, okay, why not like that? Or even this is cross. Okay, good idea. Then this is also cross. How do you know that this is not like that? So for that, actually you will have to look at, okay, this is one of the line. We understood it from the end behavior. So basically to connect with this is the nearest point. So some line must go like this. So this is the idea. Why? How do we know that this line will be something like this? Something like this. We are not saying that this is the line. Something like this. We will know it later. It's coming. But up until now, we do not know that. How this line will move. Okay, but we know that this will cross, and from this one and this one, if we connect these two information, we know that this will be like this. And see, there is a line here, so that means there's something will go there and then touch it, and then it must come here. So from this information, if we combine it, we know that it will cross this way and it will touch this way. Okay, so from the multiplicity we understand touch or cross, and then we combine it with this information, then we know how it will touch and cross. Okay, then how many turning point? You know the power is 3, so turning point will be 1 less. Power is maximum turning point will be 1 less. So this is 3, so maximum turning point will be 2. So we know that. And where is this turning point? If you want to investigate, you already can see there is one turning here. So another turning has to be somewhere here. Because this line is going down, this line is also going down. They will meet somewhere here or here, somewhere in between this space. In between these 2 points, they will meet. So maybe one turning is here, another turning is there. You can say, sir, why not a turning here? Actually, we can analyze it a little bit more, like how this line will come. Then we will realize that this line is actually not there. This will shift, and this one will also have to shift to balance it with this. These are approximate line. But we know for sure that this is a turning, and we know for sure that there must be a turning here, because these two line has to connect. That's why. So these things is written here. Turning points. for any values similar values. So this is like investigation. If x equals to 0, what happens here? If x equals to if we put different value for this function and fx, what happens at different points? We are trying to investigate, and all these results you will not have to do it. All this result is just to see what happens to the function, these individual functions. The decision about this is, and you will not have to do that part, by the way. We are just showing you what happens with the value if we put. What happens is this: near x equals to 0, what happens? And then let me show you how to do this calculation. We have two value. One is x equals to 0, another one is x equals to 3. From here and from here, two real 0, we know. X equals to 0, one value, we will do one calculation for that, and then x equals to 3, another calculation for that. Okay, if you get like 4 real zeros, there will be 4 calculations. So here only 2 real zeros, so 2 calculation. What we will do? We will try to put this 0, x equals to 0, in the place where you do not have x. In other words, other than this x, look, from where we got this x equals to 0, this term, right? So do not put x equal to 0 here, because if we put 0 here, then the function becomes 0. So other than this value, we put it here. We put it here. Then we do some calculation, we get minus 9x. What it gives us? It gives us fx equals to minus 9x. This means this is a straight line with a negative slope. That means something like this. It means at x equals to 0, the line will be something like this. Down slope. Negative slope. And slope is really, really big. That means it will be something like very almost straight. Close to straight. And this is drawn here. This is actually negative slope. If you draw minus 9x, the graph looks somewhat like this. So you see, if we put the value, we actually see how this graph will look like in real, just by putting this value. Okay, we actually can see it. Then if we put 3 in the other part, another real 0, now we cannot put 3 here, because then it will vanish if we put 3 here. So we will have to put 3 in the other place. So we put 3 here, then we get minus 3 into x minus 3 whole square. So minus 3 into x minus 3 whole square. So this tells us what? This tells us, see, this is x square, this is x square, then minus 3. That means this is the open down parabola. That means, see, this is the open down parabola. I was about to draw it here. I have to do this. So this means this minus and this x square means this is open down parabola. That means at 3 the graph is open down parabola. Okay, so this way we can determine the behavior near the x-intercept. How we can do that? We can put the real 0 in the function. Where we will put? We will put in the other place from where we got the value. X equal to 3, we found x equal to 3 from this function, so we cannot put it there, because then the function will become 0. So we cannot put it. We will have to put it in the other place to find out the behavior there. So you see, we are getting closer and closer to the accurate answer. We are getting actually accurate graph. Now, in between these 2 points, what will happen? This is like investigation. If I put f equal to 1, we get minus 4. If we put x equals to, if we put x equals to 2, then we get minus 2. This way we can, if we are confused, suppose in between this and this point, look, why we are doing this. Let me show you that. Maybe the graph will be like this. Okay, this is one. Maybe the graph will be like this. This is also same concept. Maybe the graph will come down and then graph will go there like this. We do not know. That's why we will have to put some point to understand where it may go. Now you can say, sir, then how many points we will put? Not necessarily you will not put, you will not have to put a lot of points, at least 2-3 points. Check. If two line is going to intersect, at least 2-3 points, like not more than that. More than 3 point not necessary, because we also need your estimated graph, not like 100% accurate. We need the estimation, all the concept is right, like that. So we put these points, so we get it, these 2 points. That means now we are getting that, okay, the graph is coming somewhere like this, and we can make the decision that the second turning point is between 0 and 2, 0 and 2, somewhere in between, because it is coming down, then this point, then this is up. That means somewhere here we have another turning point. So you see, if you plot these 2 points, you get better sense. Now, all the things that we discussed so far, all these things is in one page. First of all, a is negative, and this a means this is a negative sign, x cube. So end behavior is, in the left side it will go up, in the right side it will go down. X intercept is 0, 3, y intercept is 0. So 0, 0 and 3, y intercept is 0. At 0 multiplicity 1, so cross. At 3 it touch. Degree is 3, so maximum 2 turning points. Degree is 3 means degree is 3 here, so maximum 2 turning points. Near 0, like f of x equals to minus 9x, so here we got minus 9x, so this line. This is the decision from all the slides that we discussed so far. Then at 3, this is like this, so it's a parabola, down opening parabola. How do we know? X square and then minus 3, this way we know. Then 1 comma minus 4, 2 comma minus 2, these are also on the graph. We have done this calculation, just 2 points we have calculated. So all the thing, if we combine here, our graph will be like this. This is the actual graph. So the final graph is like this. This is what we wanted to draw this whole time. See, first we thought that maybe end behavior is here, but when you combine all this information, this is gave us like more clearer and clearer graph, accurate graph. Okay, we can follow these steps and we will be able to draw any graph. We will try to practice this graph during our class. Of course, we can discuss about this. You will realize actually the end behavior, intercepts, and all the things, turning points and other things. Then we will be able to draw it. And this question we will give in the participation quiz. You try to draw it, and hopefully we will give an upload button so that you can upload it sometime when you have time. Of course, by tomorrow sometime we'll give it in the participation quiz. And that's all for today. Thank you all. Thank you very much. See you all in the class. Have a good day, everyone. Bye bye.